Hey y'all, my name is Reese from Big Brainers, and today we're going to learn a little bit about the execution stack. So, the first thing we need to know to understand the execution stack is what memory is. Memory is a computer system used to store data. And what that means is it's a part of our computer, a physical component, that stores a lot of zeros and ones. So those zeros and ones are what's called binary, and they're a way of representing data. So lots of times when we're coding, we think about data as strings, so those are words and phrases, or integers, or Boolean values. These are all stored as binary, so that's what these zeros and ones are. And the computer can decode these zeros and ones and use them to represent other objects like strings, integers, floating point numbers, booleans, all of that. It's very important to consider that memory is very fast. And why that's important? We can store everything relevant to the program we're running in memory, and then take relevant data from the program at any time because of memory's super fast speeds. And one thing you might notice about this diagram over here is we have an address side and we have a value side. So what that means is that every piece of data stored in binary in memory has an address associated with it, and that's how we reference things in memory. So this address is what's called an L value, and we use it to reference the R value, which is the value of that address in memory. You can think about this a lot like variables. Variables have a name and they have a value. Similarly, memory has an address and a value. And many variables are stored in memory like this. They're referenced by their address, the L value, the L stands for left, and the R value is their physical value associated with that variable. So that could be a number, a string, anything like that. And that is the R value, or the right value. So how is memory related to the execution stack? Well, the execution stack is stored in memory. And what is the execution stack? It's a format of data that is used to handle function calls when we run programs. So the execution stack follows this idea called last in first out, or LIFO. So what this means is whatever is pushed onto the stack using the push operation is later popped off of the stack from the top. I know that's a bit confusing, so let me show a diagram right here. So a stack is made up of a bunch of frames, or a bunch of blocks, and we can stack them on top of each other, hence the name stack. So I start out with one block on the bottom, and let's say I call a function, I'd add another block to represent the function I just called. And say within that function I call another function. Now that function gets its own block, or frame, and I can keep adding frames on top and top. And let's say this function finishes. Then I can just take this frame off of the stack. And then the function that called that function finishes. I can take that one off the stack. But what's illegal to do is take a function call off the middle of the stack, because functions have to finish last in first out. And frame cannot be taken off the stack until the function it represents is completed. We use a stack and frame pointer to keep track of where these stack frames are. So, whenever we push an element onto the stack pointer will point to the memory location of the top element on the stack, or the top frame. Right now the stack pointer would be pointing right where my mouse is, right up here. And then, when I pop an element off the stack, that means take it off, at this point, the stack pointer is pointing right here. But there's also the frame pointer, which points to the bottom of the frame. That way we can keep track of each stack frame. So, once I pop this element back off the stack, these two pointers are going to change. So now the stack pointer will be pointing to the top of the stack, where the frame pointer used to be pointing. Now the frame pointer will point to the bottom of that top frame. So just to review, because I know that's a bit confusing, the stack is last in first out, which means we have to take off the top element. We can't take off any element besides that. The two operations are push, which adds an element, and pop, which removes the top element. And then the stack pointer and frame pointer are used to keep track of where each item in the stack is in memory, because remember, the stack is stored in memory. Alrighty, now let's take a more specific look at what each stack frame looks like. Every stack frame we push onto the stack will contain a return address, some arguments, and some local variables associated with that function. For example, if you take a look at this diagram on the right, we have a stack, with a couple of stack frames. So one stack frame is for a function called draw square, and the other one is for a function called draw line. And you'll notice they each have different colors to separate them from each other. So it makes sense that if we had a function that drew a square, it would call a function called draw a line. So that's why this frame is on top of the other frame. So after the draw square function was called, it called the draw line function. The first thing that's pushed onto the stack is any parameters for that function. So remember, parameters are some values that we can pass from where we called the function to the function itself. So those are the first things that are pushed on. And after that, we push on the return address, which keeps track of where our program will continue running after we finish this function. And finally, the top thing on the stack is any local variables. So any variables that we declare inside of that function will be pushed last on the stack. Let's take a look at an example for this, because this is very complicated. Alrighty, so here I have a program written in C, and it's a very simple program. It has our main function right here, which will call a function called add, which adds a couple of numbers together. So let's take a look at what the stack would look like when we run this function. So it's going to start in the main function. That's how C works. So we'll start running in the main function, and then it will call the function called add. So remember, the first thing that's pushed onto the stack is any parameters that our function had. So that was this 1 and the 7. That's the two parameters I'm going to pass to the add function. So the first thing are our parameters. That's first pushed on the stack, and these are 1 and 7. Alright, so that's our first object pushed onto the stack. Remember, the next object for each stack frame was the return address. So line 8 is where this function will finish returning. So line 8 will be pushed onto the stack after we push the parameters. And then finally, we're going to move into the add function, and we don't have any local variables. So remember, local variables were last, but since we don't have any, it will be blank. So these three parts will together form the stack frame for the add function. All right, so the add function will have parameters pushed onto the stack. It will have the return address, which is line 8, and it will have no local variables created because our add function doesn't have any local variables. After this function returns, the stack pointer, which remember points to the top of this stack, so in this case it pointed right here, will now move and point to the bottom, since this will be popped off the stack, which lowers the stack pointer's position. Alright, I hope that made some sense and will help you better understand how your program is working inside of the computer. Alright, so just to review, remember the stack is a place in memory where we keep track of function calls. So here's my place of memory. The stack is somewhere in this memory, and I'll just think of this block as the stack. Alright, and our stack keeps track of function calls, and we can push and pop function frames onto the stack. So whenever I call a function, I will add it to the stack. So I will add this function frame to the stack, and remember, each function frame contains three main parts. It contains the local variables, which are at the top because they're pushed last onto the stack. It contains a return address to keep track of where to continue running the program when the function finishes. It also keeps track of any parameters that are given to the function. Alright, so whenever we call a function, we keep adding stack frames. So if we call a function within a function, we will have a lot of frames on top of the stack, and the stack pointer will point to the top frame of the stack right above it, and the frame pointer will point to the bottom of the top frame to keep track of where these frames are and how to remove the frames when we pop them off of the stack. Alrighty, thank you.